What are we gonna go with today? Today, I consider myself, the luckiest man on the planet.
The committee will come to order. Without objection, the chair is authorized to declare recesses of the committee at any time. Welcome to today's hearing entitled Winning in Weather, United States Competitiveness in Forecasting and Modeling. I recognize myself for 5 minutes for an opening statement. I'd like to welcome everyone to this morning's hearing, Winning in Weather, United States Competitiveness in Forecasting and Modeling. This is the Environment Subcommittee's third hearing this Congress related to reauthorizing the Weather Research and Forecasting Innovation Act of 2017, an important effort for the committee at large. Today's hearing continues our examination of United States weather policy and how best to update the crucial work started by the Weather Act 7 years ago. In November, this committee unanimously passed the Weather Act reauthorization, and now we look towards the future of the United States leadership in weather forecasting. Today, we will hear from witnesses who all have extensive experience in the United States weather enterprise. Their testimonies will help us assess the United States leadership in weather forecasting and in modeling. It's easy to see that weather data doesn't just help determine the day's clothing. It enhances our national economy and security by assisting long-term decision-making. There are serious economic and humanitarian implications to not being able to predict weather correctly or precisely, and we cannot afford to let the United States fall behind on the world stage. From my conversations with farmers back home in Ohio, I know that seasonal weather predictions are vital to American agriculture. Without accurate predictions in this sector, planting and harvesting is put at major risk. Weather is also critical to the insurance industry and how to best insure homes from Cleveland to Worcester. And last but certainly not least, modeling and forecasting is crucial to all aspects of manufacturing. From planning around supply chain constraints for peak production to determining the safest transportation routes for the final product. The purpose of today's hearing is to discuss the impacts of the Weather Act of 2017 and the Weather Act reauthorization of 23 in bolstering U.S. competitiveness in the global weather community. We'll also discuss the coordination and collaboration between government agencies, the private sector, and academia to implement programs that advance new technologies related to data assimilation and modeling. Whether the data comes from NOAA, state services, or commercial providers, we must ensure that all tools at our disposal are used to make the public aware of extreme weather conditions. The United States faces the unique challenge of having some of the widest variety of weather events in the world. Just last week, the Smokehouse Creek Fire in the Texas Panhandle in southwestern Oklahoma grew to over 1 million acres in a matter of just days. At the same time, Northern California was hit by a massive blizzard which dumped feet of snow on some areas and blew gusts of wind over 100 miles per hour. In my home state of Ohio, there were 9 confirmed tornado touchdowns on February 28th just alone. Through innovation to improve the accuracy and timeliness of weather models, as well as public awareness, we can all save lives and property at risk from these events. Today, we will identify actionable items NOAA can pursue to build trust and education in weather forecasting products when an EF-4 tornado or wildfire is bearing down on U.S. citizens. There should be no doubt on the accuracy of the models and what the best course of action is to be. Additionally, by working together and increasing partnerships between NOAA and the commercial sector, the users of weather data will be better equipped to strengthen both short and long-term weather predictions, benefiting Americans across all sectors. I want to once again thank all of our witnesses for being here, and I look forward to each of your testimonies as we are here this morning. I now recognize the ranking member, the gentlewoman from North Carolina, for an opening statement.
Thank you, Chairman Miller, for holding this important hearing. As extreme weather increasingly impacts the lives of the American people, and also I want to thank all of our witnesses for sharing your time and expertise with us today. It's much appreciated. Accurate weather forecasts and warnings are essential to the protection of American lives, property, and commerce. Americans rely on dependable and accessible weather information to make important decisions every single day. Timely and accurate weather prediction is especially important in the face of extreme weather events. According to NOAA, last year, the U.S. experienced a record number of individual weather and climate disasters that each caused over $1 billion in damage. Climate change is causing an increase in the occurrence and severity of extreme weather events in the United States. That's a fact. 40 years ago, these billion-dollar disasters occurred once every 4 months. Today, they occur about once every 3 weeks. My home state of North Carolina has experienced many of these disasters. The severity and frequency of extreme precipitation events has been increasing over the past few decades and is only expected to worsen. The dangers and damage associated with severe storms cannot be stopped entirely, but they can be mitigated, including by providing the impacted communities with appropriate warnings. To that end, it is critical that we ensure our weather forecasting and communication abilities are of the highest possible quality to protect American lives and property. The importance of partnerships and collaboration among our government, academic, and industry partners cannot be understated. The integration of high-quality data collection with cutting-edge weather prediction technologies and fundamental science forms the backbone of reliable weather forecasting in this country. And this is only achieved through the collaboration of the U.S. weather enterprise. Collaboration within government is also important. There is expertise and weather-relevant research being carried out across our government. The Interagency Council on Advancing Meteorological Services, or ICAMS, that was born out of this committee's work in the Weather Act of 2017 seeks to advance U.S. weather forecasting capabilities by synthesizing the efforts of multiple government agencies along with private-public partnerships. This committee has heard from several experts, including our North Carolina state climatologists, that these types of collaborative efforts are essential to improving weather forecasting and warnings in the United States. One major hurdle to improving our nation's forecasting system is a lack of computing resources available for NOAA to support operational forecasts and data dissemination. Last year, I co-sponsored the Advanced Weather Model Computing Development Act, a bipartisan bill introduced by Chairman Miller that passed the House. This important legislation enables NOAA to leverage the Department of Energy's high-performance computational resources and collaborate on research to improve weather and climate modeling. While the refinement of accurate weather forecasts is highly important, we must also consider the unique needs of various end users across the United States. This is as much a social science challenge as a data or modeling challenge. The integration of timely, accurate weather information with effective and accessible communication is essential to our goal of protecting American lives and property. I look forward to hearing from our witnesses about how Congress can continue to support NOAA, other government agencies, academia, and industry in improving the nation's weather forecasting and warnings capabilities. Thank you, Mr. Chairman, and I yield back.
Thank you, Ms. Ross. I now would like to recognize the ranking member of the full committee, the gentlewoman from California, for an opening statement.
Thank you, Mr. Chairman. This hearing features experts with relevant expertise in a whole range of issues that we'll explore today surrounding the U.S. Weather Enterprise's efforts to improve the nation's weather and climate forecasting as well as modeling capabilities. A topic that I've been focused on in these weather hearings is the need for improvement in the subseasonal to seasonal, or S2S, there's got to be an acronym for everything, forecasts and products. The S2S predictions are important to communities and to industry, including and maybe even especially agriculture, so that adequate decision-making and planning can be made relative to water management, to infrastructure development, electricity market demands, as well as flood protection. Advancements are going to require additional research and development in quite a number of areas, and I look forward to hearing from these experts about that. While improving modeling is important, as ranking members just mentioned, there needs to be also a focus on improving the end products and the delivery of services. Dr. Petty, in his testimony, mentioned that when weighing the success in forecasting, there needs to be other meaningful metrics that are more aligned to NOAA's mission to protect lives and property. Who's the audience? What information will the end users find most useful? How should that information be delivered in the most effective way? In reaching this goal of improving meteorological services, there need to be effective collaboration between federal agencies that have relevant expertise and among the broader U.S. weather enterprise. When different agencies compete for limited funding, they become even more protective of what they have, and that sometimes constrains collaboration. At a time of constrained resources, what more could Congress do to encourage interagency collaboration? And how can the private sector and academia engage in these efforts and support advancement of meteorological sciences? These questions need to be answered to ensure that we're leveraging the nation's full expertise to further the development of weather and climate research, forecasting, and communication. On the topic of funding later today, we'll be voting on the fiscal year 2024 appropriation agreement that includes funding for NOAA. I'm glad that as compared to previous budgets that would have cut NOAA by 22%, the budget now would keep NOAA at level funding, and obviously level funding in a time of inflation is not an increase, but it is certainly an improvement over the 22% proposed cut. I also want to mention the Weather Act reauthorization bill that Chairman Lucas and I advanced to improve NOAA's forecasting and modeling abilities by expanding existing and creating new programs. I hope this bill makes it to the President's desk this year. However, I worry that stagnant funding provided to NOAA would undoubtedly slow advancement even with the good provisions of this bill. I want to thank the chairman, the ranking member, and each of the expert witnesses who are here today, and I yield back, Mr. Chairman.
Thank you, Ms. Lofgren. I ask unanimous consent to enter into the record the opening statement of Chairman Lucas without objection. So ordered. Let me introduce our witnesses. Our first witness today is Dr. Neil Jacobs. He is the Chief Science Advisor for the Community Unified Forecast System, part of the University Corporation for Atmospheric Research's cooperative programs for the advancement of Earth system science and hosted at North Carolina State University. Dr. Jacobs previously served as both Acting Undersecretary of Commerce for Oceans and Atmosphere and Assistant Secretary of Commerce for Environmental Observation and Prediction. Dr. Jacobs holds bachelor's degrees in mathematics and physics from the University of South Carolina and master's and doctoral degrees in air and sea interaction and numerical weather prediction from the North Carolina State University. Man, that is a lot. I could barely get that out, Doctor. Our second witness is Dr. Kevin Our second witness is Dr. Kevin Petty. He is the Chief Executive Officer of Eris LLC. He has also worked as a project scientist and scientific program manager with the National Center for Atmospheric Research, and as an accident investigator and senior meteorologist for the National Transportation Safety Board. Dr. Petty graduated with an MS and PhD in atmospheric sciences from the Ohio State University, OH. There it is. And a BS in mathematics/secondary education from Illinois College. Our third witness is Dr. Scott Weaver. He is founder and principal scientist of Climate Consulting LLC, and brings over 20 years of experience as a scientist and executive leading climate and weather scientific research and advancing interagency science policy across the federal government. Most recently serving as the National Director for Windstorm Impact Reduction at NIST and Executive Director of the Interagency Council for Advancing Meteorological Services at the White House Office of Science and Technology Policy. Dr. Weaver has also held scientific research and leadership positions in NASA, NOAA, NIST, and the private sector, focused on weather, climate variability, climate change, and disaster impact reduction. Welcome, and a warm welcome to all of our witnesses, and truly thank you for being here today. It's much appreciated. I now recognize Dr. Neil Jacobs for 5 minutes to present his testimony.
Chairman Miller, Ranking Member Ross, and members of the subcommittee, thank you for the opportunity to testify at this hearing on a topic that is extremely important for the future of our country's scientific leadership. Over the last few years, there have been several major successes owed to the Weather Research and Forecasting Innovation Act of 2017. Considerable progress has been made towards developing a community-friendly unified forecast system which streamlines the software architecture while embracing an open innovation approach that is mutually beneficial to the public, private, and academic sectors. This is a major paradigm shift because previous versions of the code would only work on NOAA's internal supercomputers. Engaging the broader community will not only result in greater access to innovative solutions, but it will simultaneously train the future workforce. The Earth Prediction Innovation Center is a program charged with supporting this effort. The goal of EPIC is to empower the scientific community to develop, test, and contribute their own innovations to the UFS through a transparent and objective evaluation process. This transformation is underway, but there is a lot more work that needs to be done. The UFS, which is a community model, still needs to finalize its governance that is by the community for the community, in which NOAA is a critical stakeholder. Numerical weather prediction is an initial value problem. Correctly predicting the future state of any Earth system requires observations with greater resolution and accuracy. Many of these new observations are being produced by private industry. Commercial data buy programs such as GPSRO, commercial aircraft data, and the National Mesonet program are cost-effective ways to greatly improve model accuracy. While acquiring data for more advanced observing systems is a critical step to improving forecasts, we cannot lose sight of an equally attainable opportunity, which is extracting more value from the data that we already collect. The process of data assimilation, such as the JEDI framework, is often overlooked, yet it is one of the most important aspects of numerical weather prediction, where significant returns on investment are easily attainable. Another challenge we are facing is how to manage the new data when those file sizes are growing exponentially. As files get larger, transfer speeds get slower. The mission of the National Weather Service is to protect life and property, where often seconds matter. Increasing the latency of data availability, even if it is more accurate, is counterproductive. Whether it is satellite data, forecast models, or processing and visualization tools like AWIPS, cloud is the answer. We must evolve beyond a process that relies on moving data. Not only does cloud computing eliminate the latency problem, the elasticity of on-demand commercial cloud also eliminates the bottleneck of limited access to compute research for research and development. Efficiencies throughout the value chain of forecasting can also be gained from artificial intelligence. I am encouraged by NOAA's rapid adoption of various AI and deep learning techniques, and I'd like to thank the committee for supporting this emerging capability in the Weather Act reauthorization. While these are a few technical gaps that need to be addressed, there's a broader overarching aspects that are essential to accelerating progress. Workforce recruitment, retention, and development is a growing challenge. There are very few opportunities for the current workforce to upskill or reskill to adapt to rapidly evolving technological advancements. While software engineering is a common field at most universities, finding engineers with a solid understanding of atmospheric physics and dynamics is not easy. Additionally, the programming skills needed for model development are similar to those required in other job markets where the starting salaries are far more competitive. There's a growing number of Earth System Science degree programs within the U.S. universities, but many are limited in their ability to introduce students to model code. Versions of the UFS, through support of NOAA and the National Science Foundation, are being developed for use in the classroom as a teaching tool. Being able to run a global model without access to large supercomputers was unimaginable just a few years ago. However, we now have versions of the UFS that can run on public cloud, as well as a laptop. While this is a game-changing capability to train the future workforce, we are now just approaching the start line for this race. Chairman Miller, Ranking Member Ross, and members of the subcommittee, thank you again for inviting me to participate today. I would be pleased to answer any questions you may have.
Thank you very much, sir. I now would like to recognize Dr. Kevin Petty for 5 minutes to present the testimony.
Chairman Miller, Ranking Member Ross, and members of the subcommittee, I want to thank you for the opportunity to share some thoughts and perspectives related to the weather enterprise, particularly from the standpoint of U.S. competitiveness in weather forecasting and modeling, now and into the future. I've had a long career working in the weather enterprise. I've been fortunate enough to work in the public, private, and academic sectors. Most recently, I joined the leadership team at Eris LLC, a small Colorado-based team that is focused on the development and application of environmental modeling at meter scale resolutions. These diverse positions and experiences have helped to shape my perspective on the weather enterprise, particularly what has worked well and what has not. Here in the United States, we face distinctive weather-related challenges that are not seen in other parts of the world. Factors such as a changing climate, population growth, increased complexities associated with the built environment are all shaping the need for accurate, timely weather data and information. The ability to achieve significant measurable improvements in weather analysis and forecasting is rooted in 4 fundamental areas: in observations, in computing, in modeling, and information delivery. Unfortunately, no single entity or sector of the enterprise has the capacity to meet the depth and breadth of the demands associated with each of these domains. That said, our country has successfully developed something that no other country has been able to replicate, and that is a strong, robust weather enterprise where public, private, academic, non-governmental organizations have the ability to support the common goal of protecting life and property and ensuring a strong, vibrant economy. The U.S. competitiveness in weather forecasting and modeling is highly dependent upon our ability to effectively leverage the strengths of each segment of the weather enterprise. Now, it goes without saying that the U.S. weather enterprise would not be what it is today without NOAA. NOAA is and will remain a central component of the weather data and information value chain. Many companies like my own depend on NOAA to produce very high quality data, including weather forecasts. Nonetheless, like other segments of the enterprise, NOAA must continue to rapidly evolve if it's going to be a driving force in terms of being a preeminent leader in weather forecasting globally. We've seen other components of the enterprise quickly hasten the pace of innovation, and this is particularly true from the private sector's perspective. The private sector has made significant investments and advancements in the development of new observing systems, in the use of artificial intelligence, in pushing the boundaries of modeling from the standpoint of spatial and temporal resolution. The Weather Research and Forecasting Innovation Act of 2017 has helped to guide recent NOAA activities in several positive ways, including from the standpoint of encouraging commercial weather data buys, highlighting the importance of expanding and upgrading computational resources, and providing concrete direction on weather research and forecasting priorities. However, there is more work to be done. If we're going to be the leader in weather forecasting and modeling, it is imperative that NOAA have the continued support and direction it needs. With these elements in place, NOAA should formulate a clear, concise weather forecast improvement strategy with defined trade-offs. This should also include well-defined, agreed-upon metrics for improvement. NOAA should also carefully consider whether its current structure can foster the desired level of innovation. And finally, NOAA should build deeper, more collaborative research and development partnerships with industry. In conjunction with NOAA's efforts, Congress should support NOAA by not overtaxing NOAA with new responsibilities that do not deliver targeted value, particularly if they don't come with a supporting budget. Congress should also adhere to the established timeline for the budgeting process. Federal agencies such as NOAA can't be expected to be innovative forces in terms of improved forecasting without the capacity to effectively plan. The lack of budgets also has a cascade effect on NOAA's partners. I want to thank you for this opportunity to present this testimony, and I welcome any questions or comments you may have.
Thank you, Doctor. I now recognize Dr. Scott Weaver for 5 minutes to present his testimony.
Thank you. Chairman Miller, Ranking Member Ross, and members of the subcommittee. I'm Dr. Scott Weaver, founder of Climate Consulting LLC, a new consultancy focused on science and policy issues in weather and climate. I've also served in several scientific leadership roles within the federal government, including as a research meteorologist for NASA and NOAA, Director of the Interagency National Windstorm Impact Reduction Program led by NIST, and most recently as the inaugural Executive Director of the Interagency Council for Advancing Meteorological Services, or ICAMS, at the White House Office of Science and Technology Policy. Thank you for the opportunity to appear before you today. The ICAM's aspirational goal, as stated in its 2020 charter, is the United States will lead the world in meteorological services via an Earth system approach, providing societal benefits with information spanning local weather to global climate. So the question before us today is essentially, what are the requirements for the United States to lead the world in meteorological science and services and ensure that all sectors of American society are prepared for the pervasive weather threats that menace our country on an increasingly frequent basis? This is a timely question. Since 1980, the United States has experienced over $2.5 trillion in economic losses and over 8,000 fatalities from extreme weather events, with $1 trillion of those losses occurring in the last 7 years alone. These weather disasters highlight a somewhat uniquely American experience. No other country in the world faces such a diversity, frequency, and intensity of extreme weather events. As such, our national weather prediction efforts are challenging by comparison, and in some instances require targeted, phenomenologically based modeling approaches that may not be as necessary for other countries. Indeed, the U.S. experiences approximately 1,400 tornadoes per year on average, dwarfing the annual tornado count of any other nation in the world. Despite these challenges, our nation has made significant progress in numerical weather prediction. One shining example is the reduction in the average 3-day hurricane track forecast error from 450 miles in 1970 to just 50 miles today, an incredible achievement. Nevertheless, there still exists a critical need and an incredible opportunity for the United States to lead the world in meteorological science and services. To achieve this requires coordinating a thriving research and applications enterprise to finally begin to bend the curve in the nation's annual weather disaster losses. Given that ICAM's agencies invest almost $6 billion annually in the meteorological enterprise, it is critical that the federal government strengthen coordination of its own meteorological assets. However, significant obstacles exist. Varying missions, budget development approaches, and legislative requirements make it challenging to effectively develop shared priorities and practices across the range of meteorologically sensitive federal agencies. In recognition of these challenges, Congress created ICAMS to elevate federal coordination of meteorology to the White House level. In response, the White House and the ICAMS agencies chartered 4 standing committees, one on observations, one on computing, one on services, and one on research and innovation. If properly resourced and supported, this structure has the potential to accelerate progress on an array of important issues in meteorological science and services, including numerical weather prediction. Through these committees, ICAMS has achieved some success already, including advancing interagency coordination of meteorological science priorities for wildfire and initiating the development of the first ICAMS Decadal Strategic Plan, an effort that must continue for ICAMS to achieve its goal. Despite these bright spots, I am concerned that ICAMS may never reach its full potential. Strengthened provisions are needed in the Weather Act reauthorization to ensure that ICAMS remains elevated as a top national priority, so that it can effectively respond to urgent and rapidly evolving national needs. Indeed, over the last 2 decades, the meteorological enterprise has undergone revolutionary changes, the most notable of which is the rapid evolution of the private sector from primarily developing end-user products and services to that of a multi-billion-dollar commercial enterprise that is in direct competition with the federal government to provide the very foundational data, modeling, and information that was once only the purview of federal meteorological agencies. This rapidly evolving landscape requires a nimble and effective national strategy to make what amounts to an order of magnitude change in how the federal government leverages the commercial sector for mutual benefit. In closing, I provide several recommendations for consideration by Congress and the President. These include mandating the completion of the ICAMS Decadal Strategic Plan, reimagining the Interagency Meteorological Coordination Office, unleashing the private sector by aligning relevant federal and commercial research and development goals, fostering engagement at the agency head level to inform federal agency budget development activities, and implementing mechanisms to encourage and enable the participation of non-federal stakeholders in ICAMS. I thank the committee for its recognition of the need for a strong meteorological enterprise. I look forward to our discussion today, and I'm happy to answer any questions you may have.
Thank you very much, and I thank all the witnesses for their testimony. The chair recognizes himself for 5 minutes of questions. Dr. Jacobs, I'd like to talk about NOAA's commercial programs because the United States is unique in having many weather startups and innovators. NOAA has been operating the Commercial Weather Data Pilot Program for a few years now with the success despite what some might call hiccups in organization and structure. I understand NOAA tends to offer short-term contracts for 6 months at a time and then recompetes those all over again. Do you believe that this has a chilling effect on the commercial sector or limits the full potential of a thriving commercial data market? Or even is it correct to say that the commercial weather data industry is one of the most valuable assets in the United States has when compared to global competitors?
It's a hugely beneficial program. So a lot of commercial data that's available, it has a huge impact on the forecast models. It's really, really valuable. There's more out there that can be acquired. A lot of these companies are producing data at a rate faster than NOAA can acquire it. I would say that from an investor standpoint, I hear often a lot of issues with confidence and long-term investment in developing and deploying these programs if they're faced with short-term contracts. So a lot of times there's what we call non-recurring upfront engineering to deploy and build out these networks to sense things like weather. That's expensive. And these companies would like to have more confidence that they're going to get a long-term return on their investment before they deploy a lot of these assets.
Thank you very much, and that tracks and makes sense, and I appreciate your testimony. My next question is going to be for all of our witnesses to chime in on, so feel comfortable to go on in. One reason that I called this hearing today was to help us better understand why and how the European global model has been labeled the gold standard. I understand that the Europeans largely have the same data that we do, but they focus heavily on improving their internal model code and data assimilation. So can each of the witnesses, if possible, give their opinion on why has NOAA fallen behind on data assimilation, and what can we do to catch back up?
There's a couple different reasons. It's true, the European Center has had a more skillful global model for quite some time. I would like to point out that NOAA runs several different models on different forecast horizons, and they're by far the leader at all with the exception of the global model. The U.S. model has been anywhere between second and fourth as far as forecast skill. And while there are some data sets that the European Center may use that the U.S. doesn't, it's primarily related to data assimilation. The European Center, as well as a couple other skillful models like the UK Met Office, use four-dimensional variational assimilation. The U.S. doesn't use 4D-VAR yet, although there is a system in development for 4D-VAR. The trade-off is 4D-VAR is extremely computationally expensive to run, and it requires a tremendous additional amount of compute both to run it and test it. And that was kind of the decision back in the day, was with limited compute resources, how do we divvy up the different models based on the trade-offs? And it turns out that 4D-VAR, I think, is going to add the most value.
Thank you.
I would add from the standpoint of maybe organization and what the focus is. As noted in several testimonies you heard today, the U.S. itself has a number of different issues that we have to target when it comes to weather. And the timescales are really broad, everything from nowcasting to medium range to longer term type of forecasting. When we think about the Europeans and the ECMWF specifically, they have a very targeted, focused mission that really helps with their efforts of advancing what they do. They do not have to spend the time really deploying resources in so many different areas because of their focused mission. The other thing that I might add on top of that is really the aspect of being diluted is quite challenging for us in the United States. And if we can have a more focused way of targeting improvements and have the right metrics, that is key. What does it mean to have forecast improvement? We can talk about 500 millibar height, or we can talk about how have you forecasted tornadoes. And so really having focused metrics is something that we need to consider.
Thank you.
10 seconds can't really add much, except to say that I typically view the meteorological enterprise larger than just the modeling component. Modeling's foundational. But there's a greater enterprise out there that we can also be focused on in addition to just the foundational modeling.
Thank you all very much. I now recognize Ranking Member Ross for 5 minutes of questions.
Here we go. Thank you again to the witnesses for joining us today. While the discussion of our weather model's performance is highly important, at the end of the day, the goal is for there to be effective and actionable weather information that aids decision makers and protects lives and property. Researchers have found that in some cases, increased warning time for extreme weather can lead to a lack of action as less urgency is perceived. There also has been research to suggest that messaging on personalized impacts can lead to significantly higher evacuation rates. But at the same time, recipients of that information found it to be more overblown. Dr. Jacobs, if the U.S. were able to achieve a perfect weather model, there's still a possibility that the public would not react as intended to certain information. We certainly see that in North Carolina. How can NOAA and the U.S. weather enterprise improve the human response to the information that it puts out?
Thank you very much for that question. So as someone who focuses on numerical weather prediction, I had always thought the more skillful the forecast, the more lives you would protect. And you're absolutely right, particularly with tornado warnings, more lead time doesn't always translate to more lives saved. This is really a social science issue. It comes down to how do you translate this information into actionable decisions that result in behavior that is going to protect life and property. I think there needs to be a focus on really translating this through the social scientists that the National Weather Service is bringing on board. But additionally, one of the things that they don't have is they don't have verification data. They don't have circumstances of how lives are lost. So it's really challenging to sort of figure out how do you test and evaluate different sort of criteria of messaging, because you may have a tornado warning. You don't know if the person got the warning, didn't get the warning, got the warning and didn't know what to do, or got the warning and knew what to do but didn't have the means to do anything. There's a lot of different variables other than just doing damage assessments that we need to actually test and validate these different metrics and prediction tools that are coming from the social science community.
Dr. Petty, I see you nodding your head. What can the private sector add, and do you have anything to add to what Dr. Jacobs has said? And of course, we'll give Dr. Weaver an opportunity as well.
Yeah, I think Dr. Jacobs hit it the nail on the head, that the social science component is so important. And from the private sector standpoint, the private sector stands poised to be a partner to NOAA when it comes to translating that information into actionable information that people can use. And so I think that's where the private sector can really provide a considerable amount of support.
Okay, Dr. Weaver, do you have anything to add?
Yeah, I have something to add. So when I think about this from the 10,000-foot level of an organization like ICAMS and all the different federal agencies, I've had the pleasure to work at NIST for several years, which is sort of an odd place for a meteorologist to end up. But what was great about that was I got to work with engineers and social scientists and a very large interdisciplinary team that even included epidemiology experts. Okay, so this is very interdisciplinary. And this team would study the impacts of weather disasters. So they would go out after the forecast was made, after the forecast was no longer meaningful, and they do sometimes multiple year-long longitudinal studies of the entire disaster, the social components, how communities recovered, did they get the information, what was the meteorological science like, the entire scope. And so I bet you if I told 100 meteorologists that NIST does this, maybe a few of them would know. And so this is why something like ICAMS is so important, because this is where that information trading and understanding what different agencies do can be so important. So I'll also put a plug in and say, it's time to reauthorize the National Windstorm Impact Reduction Program. That is the program that does a lot of this. And it's not in the Weather Act per se, but it's a very close relative, and I think it's vitally important as these, like I said in my testimony, I'd like to bend the curve in those increasing billion-dollar disasters, and investigating the different components, whether it's engineering or social science afterward, is critical to that effort.
Well, Dr. Weaver, we're so glad that you are testifying today. And Mr. Chairman, I'll yield back.
you, Ms. Ross. I now recognize Mr. Posey for 5 minutes of questions.
Thank you, Mr. Chairman, and I thank the witnesses. Dr. Jacobs, does NOAA Weather Services Aircraft Observation Program have the ability to obtain contrail data from aircraft, commercial aircraft?
So they don't actually record the contrail data itself, but all commercial aircraft record wind and temperature information, and several commercial airlines also record relative humidity information through different sensors. And temperature and relative humidity are the variables in which you would be able to forecast and predict contrail conditions.
Yeah, if NOAA doesn't have the ability to do that, are there other commercial companies that can provide that data to NOAA?
There are. In fact, there's a lot of different commercial companies that pull down different data. All, like I said, most of the commercial airlines collect this data. It's just a manage of having a commercial data by contract to get the data, primarily to cover the cost of communications to run the data off the plane. But the data does exist, and there are commercial companies that provide it now.
Okay, so NOAA does or doesn't have the ability to model contrails and tell constituents and the people, American people, when and where they will form, and if they can predict them into the future?
They don't, to my knowledge, do a forecast specific for contrails, but they do forecast temperature and humidity at the flight levels which the planes fly, which you can use those variables to derive conditions when you would know contrails would exist.
Okay. Just three, yes or no. Do you support NOAA improving aircraft programs so it can be able to provide more weather data as well as contrail data from aircraft?
Yes.
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 Thank you. Dr. Weaver and Dr. Petty, are there current commercial data providers whose data would drastically improve the U.S. forecasting models?
Yeah, I think there are several companies out there. I slightly misspoke earlier, but what I wanted to hit on was that there's an acceleration in innovation, and you can see that innovation across these new observations, whether they be space-based or airborne observations or terrestrial. So there are opportunities out there for NOAA to acquire additional data sources.
What do you think the role of infrared sounding plays in creating weather forecast? You know, how can we incorporate more of this data into U.S. models, and what would the impact be?
So, I mean, as Dr. Petty was discussing, that there's plenty of data sources out there, right? So it's not just about infrared, and I'm not an expert specifically on infrared, but I am aware, as I mentioned in my testimony, that there are several private sector companies that are rivaling the capabilities of the federal government, and this is something that we have to deal with and figure out a way that we can use all of the data, whether it's being collected by the government or the commercial sector. So I know of several companies that are doing quite revolutionary things in terms of radars on satellites or radars on the ground, et cetera. And you know, these are very valuable data sources that would certainly, you have to work with your government partners, though. You can't just throw the data out there and expect them to be able to know how to assimilate it. It's got to be a co-production as this goes along through time, right? So, because we have standards that we have to meet in terms of weather forecasting in the federal government. We can't just throw anything at it, and so it has to be quality controlled and, you know, assured through some research that these are adequate data sets for their purpose. And so,
what's the role of calibration and data continuity for both short-term weather and longer-term climate predictions?
okay.
Either.
Yeah. So, I mean, it's very important for longer term climate predictions. I mean, one of the things that we must do, even in the short term climate predictions, things like seasonal, right, which is, you know, varies year to year, et cetera. Those kinds of phenomena, you need to have a very consistent database through time to understand them first, and then be able to predict them. So we do have something in the climate and weather community called reanalysis, which tries to go back and collect all the observations through time and then streamline them, or quality control, if you will, to make them, you know, an observation taken in 1980 would be similar to the one today, but they're not. So you need to figure out ways to put them on an even keel.
Gotcha. I see my time's out. Mr. Chairman, I yield back. Thank you.
Thank you, Mr. Posey. I now recognize Ms. Lofgren for 5 minutes of questions.
Well, thank you, Mr. Chairman, and thanks to each of these witnesses. Very interesting, and I've learned some things this morning, which is always a treat in the Science Committee. Obviously, we have challenges not only in data collection, but data assimilation and distribution. I have a question about, once those challenges are addressed, which may take a while, how are we thinking about using AI, if at all? I mean, NOAA had a pilot project in partnership with a company that specializes in AI language software to translate weather information more accurately and efficiently into different languages. And so that would be more accessible to non-English language speakers. But it occurs to me that there may be a greater capability with AI. I'm wondering what each of you thinks about that, and then also how do we deal with the persistent problem of hallucinations? So if each of you could address that, I would appreciate it.
I think there's a tremendous opportunity for AI all across numerical weather prediction, even down to potentially replicating the entire modeling system. So right now, the current state of the art is physics-based models. AI can replicate a lot of what those algorithms do. And the advantage, I think, with AI is that you can run this on a tiny fraction of the amount of compute. But you still need the physics-based modeling systems and the observations and the data assimilation to build, at a minimum, a training data set to train the AI systems on. So I don't think we'll ever see a situation where we can predict the weather going forward in the future without correctly observing the atmosphere, because it's an initial value problem. But I think there's huge potential benefits to gain from AI in optimizing the speed and efficiency of which the physics-based models predict the weather.
Thank you. I mean, I didn't mean to suggest that we wouldn't need the actual data. Obviously, we do. But how we assimilate and crunch it could be of value.
It is. Well, I often hear people talk about how AI is going to replace physics-based modeling. And I don't understand how that's theoretically possible, because you'll always need this type of system to do the training and the error analysis on the observing systems.
Correct. Dr. Petty, do you have any additional comments?
I would just echo Dr. Jacobs, but I would add, even beyond our ability to leverage AI from the context of forecasting improvement, I think we're going to see it in other areas of the entire value chain, all the way down to how do we translate data into actionable information. I will admit I was one of those individuals who was a little bit kind of standoffish, if you will, on AI, but seeing what has been done in the last couple of years, it's going to be a powerful tool.
Yeah, so obviously we're at a technological revolution here. I certainly agree with what my two colleagues here have just said regarding the training and where we're going with this. When I was a research scientist, and all day, every day, you're looking at that, just looking at data and trying to understand things, we live in a culture of doubt. I know that's surprising for some people, that we are not always as sure as we would like to be. And that's part of the scientific process. You're always doubting your results. So when I see these papers coming out that are like, we're beating, numerical weather prediction, et cetera, it's very exciting to see that. I'd like to see more. Yeah, I've only seen a few, so maybe there's more. I don't know, but that could just be the scientist and the culture of doubt. If what some of these claims are making are really true, then that's fantastic. Because when Neil was talking about the training, once you train the system, it's over. Then you just need to run it, right? And that could be done on a laptop, whatever, right? You don't need the massive amount of compute once you have the system.
Well, you need to train the system,
yes.
but you still need data for it to crunch.
100%. I mean, yeah, so we need both, but the idea here is the forecast can be done much quicker because you've trained it already, essentially. You don't have to wait for it to crunch out through. So very exciting time. I'd like to see a little more personally, but that's just my own opinion.
Of course. I know putting you on the spot, but if you have, after this hearing, some thoughts on how to deal with guardrails as well as the hallucination problem that is persistent, I'd be eager to hear it after the hearing. With that, Mr. Chairman, I yield back.
Thank you, Ms. Lofgren. I now recognize Mr. Collins for 5 minutes of questions.
Thank you, Mr. Chairman. Dr. Weaver, I kind of want to pivot off of that just a little bit. Maybe not pivot, just ask some more questions about it because there's several things here at play. Like we all have talked about for the past year about China and the threat as being one of the greatest threats to our country that there is. And I know that they do a good job of AI. And I guess first question is, where do we stand in relationship to China on the AI race, and maybe some quantum computing in there as well?
Yeah, so I'll be honest with you. I'm not an expert on where we stand with China in terms of AI. So I wouldn't really have much to add to the hearing on that. I don't know if any.
Do you think their AI modeling is pretty good? Have you seen any of their forecasting modeling?
I have not. Therefore, I can't really comment on it.
Anybody?
I have not seen their output. I think one thing that I would maybe caution, and I think this is what Dr. Weaver was referring to, is when we hear claims about these models, it's really important to understand, well, how are these models, AI models, verified, and what were they verified against? And until we can see, those data and how that was done, it's very difficult to ascertain how well maybe the Chinese or others are doing. So there really needs to be
Well, I mean, isn't
rigorous.
it's easy to verify it after the fact, whether or not it was true or not, right? Whether or not it happened.
But a lot of times in science, when you're doing that verification, you need to know the methodology that was followed, so that methodology can be replicated and make sure that was done correctly. And I, from kind of your question about the Chinese, I don't know if they're verifying against 500 millibar height or temperature at the surface or wind speeds in New York, and really having that thorough verification is helpful.
Right. Well, I've been in small business for over 30 years, and just seeing the accelerated advancement of AI, even in the transportation industry, which I'm in, it's just amazing. And I would like to know where NOAA stands and where we stand from a private industry standpoint in the country, because there is a race, and China spends more money than the entire world on quantum technology and quantum computing, and that's in everything, not just defense, not just hacking, and because they want to rule the world one day. Dr. Jacobs, I was walking in, so I'm sorry, we've been kind of running around like crazy here this morning. You were talking about cloud computing. Is NOAA ready for artificial intelligence? And
So right now, they're testing out a couple different AI systems to replicate a lot of what the physics-based models are using, and they're showing a lot of promise. As I was saying earlier, I think the benefit there is you save on computational resources, at least for the operational prediction system, but you still need to generate the training data sets. When it comes to cloud, NOAA's definitely headed in that direction, as well as a lot of the private sector, most of the universities. I think a lot of, at least in the private sector, I don't really know any companies that own their own high-performance computing anymore.
Right.
They pretty much all use commercial cloud. The beauty of commercial cloud is probably more seen in the research and development than it is in the operational, because you buy on demand. You only buy what you need, and when your research needs fluctuate, that's an extremely cost-effective way to do it, because if you have a series of experiments that you want to test with traditional on-premises high-performance computing, you only have a limited amount of resources, so you run the experiments one at a time. With the commercial cloud option, you can pay for all of these experiments to be run in parallel simultaneously. It costs the same whether you run them all at the same time or one after the other, but the beauty of running them all at the same time is you get the research done faster.
good. Hey, I've got one other question. I know we're down to less than 25 seconds. But Dr. Jacobs, I introduced the Weather Information for Agricultural Act, and I didn't know if you could take just a minute to explain the advances in drought weather modeling and how it can best be used by farmers.
There's a lot of advancements, and actually there's a lot of work being done on seasonal and subseasonal prediction with AI too, because a lot of it, there are dynamic models that run out to 9 months, but a lot of this is pattern recognition, seasonal patterns like INSO and PDO and things like that. That's actually a really unique spot for AI. So I think there's a lot of advancements being done on those different forecast horizons, and most of the agriculture community, they know exactly how to use the data. They just want to know both what is the prediction and what is the confidence in the prediction.
Right. Thank you. Sorry about that, Mr. Chairman. I yield back.
No worries. We'd like Mr. Frost for 5 minutes of questions.
Thank you, Mr. Chairman. I represent Central Florida, and in Florida we get a lot of hurricanes. Every hurricane season, friends, family, siblings, myself, we see an increasing number of dangerous storm systems develop and make their way towards our state. Mr. Jacobs, or Dr. Jacobs, first off, I want to thank the work that you're doing and that NOAA and all the staff are doing. This past hurricane season, I spent a lot of time at our county and city EOC with the city of Orlando and county. When I asked them how their relationship is with NOAA, they have nothing but good things to say about your staff and the work that y'all are doing and keeping us safe in the entire state of Florida. So I appreciate that. Dr. Jacobs, when it comes to hurricane preparedness, why is it important to understand the relationship between climate and weather?
Well, climate modulates the weather. And so while we have the ability to predict the weather, particularly when it comes to hurricanes, the fuel for those is the sea surface temperatures. And we also have seasonal influences. For example, this last season, the prior one, we had El Nino, which in the Atlantic, there tends to be a lot of shear, which prevents the development of storms. That's nature's way of removing heat and transporting it towards the poles. And so as we transition into a La Nina year, I think the seasons will be a good bit different. But understanding the relationships between the changing climate, the influences that feed these storms, that, I think, there's a lot of research that needs to be done there. The exciting thing to me is the capabilities in forecasting these storms, both track and intensity, are really, really improving. But one of the areas in hurricane forecasting that I think needs additional work and focus on is rapid intensification. We always see storms that when they come into the Gulf, particularly over the loop current, there's a tremendous amount of rapid development that the models struggle to handle. And that, I think, is an area where there needs to be additional work and research above what's being done right now.
Yeah, I mean, in the event of a hurricane, good forecasting modeling can really save lives. Where have you seen gaps in successfully communicating the severity of these storms to people?
I think that there's work to be done on the track forecasting. I got to give a tremendous amount of credit to the Hurricane Center. They just rolled out a new way to sort of visualize the cone based on impacts. But there was, a translating model, both the projection and the uncertainty is tricky, because a lot of people tend to focus on just the center track of the storm when the effects of the storm could be hundreds of miles away. Having people being able to visualize the impact of a storm surge. It's one thing to just say this storm surge may be 5, 10, 15 feet. It's another thing to actually be able to visualize how high 15 feet of water is. Mm-hmm. Getting this message out there, I think, it's largely a social science problem. We even though we're improving the skill in the models, we still need to figure out better ways to message, to visualize the output in a way that solicits a proper response.
Yeah, I have a bipartisan bill with Congressman Webster on this committee. The Fixing Gaps in Hurricane Preparedness Act is actually included in this committee, the Weather Act. And it would direct NOAA to study the ways that most at-risk populations, seniors, folks with disabilities, people who speak different languages, how they react to hurricane forecasts and communications that come from the government. Dr. Jacobs, do you think focusing on these types of populations align with what you think some of the gaps are?
Absolutely. I think that one of the biggest challenges, and we've seen this with tornado watches and warnings, but it's the same thing with the hurricanes, is we need verification data. do the people understand the warnings? If they do understand the warnings, do they know what to do? If they do understand warnings and they know what to do, can they take action? There's a lot of different situations where people, even though they know exactly what to do, for one reason or another, don't take action. Maybe they can't take action. And this, I think, this needs both verification information from the circumstances of all these different populations, as well as tailored messaging.
Yeah, the bill directs NOAA to do the study, but really will have impacts for municipal government, state government, federal government, and all types of nonprofits and players in this space who help reduce the amount of lives that we've seen lost during these intensified storms that are getting lasting longer and creating more devastation due to the climate crisis. So I appreciate your work. You know, last hurricane season, I had a great offer from NOAA to hop on the Hurricane Hunters plane. I was unable to do it just because it was my first hurricane season, and I want to make sure I was home, but next time I think I'll hop on. Thank you. I yield back.
Thank you, Mr. Frost. I just want to say I want to thank all of the witnesses for their valuable testimony and the members for their questions. The record will remain open for 10 days for additional comments and written questions from members. Once again, thank you to our witnesses. This hearing is adjourned.